So let's continue with question 3 because it involves ratio. So determine the relative atomic mass of element Z if the atomic mass ratio of Z to carbon-12 is 1.17. So this is how you extract this information. So for this question, the mass for carbon-12 is not 12 anymore. Okay, and why is that? It is because for the ratio of Z over carbon-12 equals to 1.17, it must be over 1. So the mass of Z is 1.17 and the mass for carbon-12 is 1. So let's figure out the relative atomic mass. So the mass of Z divided by 1 over 12 times mass of carbon-12, which is equal to, so mass of Z would be 1.17 over 1 over 12 times the mass of carbon-12, again it is 1. So the final answer would be 14.04. So you try the question 4, which is not given in ratio but in multiplication, because the question said heavier, more. Alright, for question 5, 6 and 7, I'm going to give you the hint how to solve it. Okay, so the rest I want you to do it by yourself, because it is quite easy and you guys just need some guidance to do question 5, 6 and 7. For question 5, the isotopes of silver occur as 107 Ag and 109 Ag with mass of this one and this one. So you are given the average atomic mass of 107.868. What would be the percentage abundance of these two isotopes? Okay, when mentioning about abundance, you know that you gonna have to use the Aam formula. Okay. But first, let's extract out the information. For 107 Ag, the mass is 109.906. For 109 Ag, the mass is 108.868. So let's substitute the mass information into Aam formula. So average atomic mass is equal to sum of Chemi over Q. Okay, so we don't know the abundance for both isotopes. Okay, so since the question asks you for the percentage abundance, so you can assume that the percentage abundance for 107 Ag to be X, and the percentage abundance for 109 Ag to be 100 minus X. So let's substitute this percentage abundance into this formula. So the average atomic mass is given already, 107.868. 8 equal to 109.906 times x plus 108.868 times 100 minus x. So you finish off this question and you should be able to get the percentage of abundance in this final answer. Okay, you can compare it. For question 6, it is the same as question 5, but question 6 mention you to find the relative abundance. Okay, so what you need to change is, remember in the formula, okay, for relative, your second isotope abundance must be 1 minus x. Okay, so I'm just gonna write it here because I don't have any space below. So the relative abundance for 79Br would be x. For 81Br, the relative abundance would be 100 minus, that would be 1 minus x. Okay, so just substitute the information into the formula and you should be able to find the relative abundance in this number. Okay. I'll give you the hint for question 7 as well because the information is in ratio form. So chlorine has 2 isotopes, which is in the ratio of 3.1 to 7, and you are given the mass as these numbers in the question. So the first question, calculate the percentage abundance of each chlorine isotope. So again, like question 2, if I'm not mistaken, the ratio should be written 35 Cl over 37 Cl is equal to 3.127 over 1. So 35 chlorine is 3.127. Sorry, the abundance for 35 chlorine is 3.127, and for 37 Cl the abundance is 1. But the question asks you to find the percentage abundance. Okay, so I'm gonna show you how to find the percentage abundance for 35 Cl only, and you carry on the rest of the question. So 35 Cl, the abundance is 3.127 over the total abundance times 100%, because we're gonna find percentage abundance. So that would be 75.77%. So next, you're gonna figure out the percentage abundance of 37 Cl and answer the question B as well. And I'm gonna leave you the question 8, and I'm gonna check it in the next class. Okay, try to figure it out by your own.